Hello everyone. Welcome to numerical series of electrical machine. And today our numerical problem is based on polyphase machine. In this video, we have almost 5 numerical problem, and this question is frequently asked in the exam of Pokhara University. And today our first numerical problem is, in this video we have already 5 numerical, and each are of similar type. So first numerical problem is, a three-phase induction machine is owned for a 4-pole and is supplied from 50 Hz system. Calculate synchronous speed, the rotor speed when sleep is 4%, rotor frequency when uh, motor runs at 600 rpm. In the question given, pole equal to 4, frequency 50 Hz, and we know synchronous speed equal to 120 f by p. So 120 f into 50, 50 is the frequency upon pole 4, so 1500 rpm. The rotor speed when sleep is 4%, that is sleep is 0.04. Then rotor speed equal to, we know the formula, n equal to ns 1 minus s, so 1500 into 1 minus 0.04. Then we can get 1440 rpm. And last one is rotor frequency. Rotor frequency at n equal to 600 rpm. Then we know sleep equal to ns minus n upon uh, ns. So from this we can get the value of sleep. And rotor frequency, this f dash is rotor frequency, so rotor frequency equal to sleep into f. Put this value of this sleep, so 0.6 into 50, that is, this the rotor frequency is 30 hertz. And our next numerical is a 12 pole 3 phase alternator driven at a speed of 500 rpm supply power to an 8-pole 3-phase induction motor. The sleep of motor at full load is 3%. Calculate the full load speed of the motor. And first of all, n, actual speed of the motor, we know n equal to 120 f by p. So from this equation we can get the value of frequency, that is 50 hertz, and synchronous speed is 120 f upon p. So we can get the value of ns is 750 rpm. And this sleep is already given 3%, so 0.03, and we know sleep equal to ns minus n upon ns. So put all this value, we can get the value of n. And in the question, calculate the full load speed. So this is the speed of full load. This is numerical second. And numerical third is like this: a 3-phase induction motor having star connected rotor has an induced EMF of 80 volt between slip ring at standstill on open circuit. The rotor has a resistance and reactance per phase of 1 ohm and 4 ohm respectively. Calculate current per phase and power factor. Next one, in this condition we have to calculate current per phase and power factor. And condition first is sleep rings are short circuit, and sleep rings are connected to a rheostat of 3 ohm per phase. First of all, induced EMF 80 volt, R2, this is the value of resistance 1 ohm per phase, and X2 4 ohm per phase, this is the value of reactance. This is already given. And so condition first is sleep ring at short circuit. Standstill EMF per rotor phase is E2, that is V upon root 3, that is 80 upon root 3. We have to find the voltage per phase, that is 46.18 voltage. And we know the value of current, I2 equal to E2 upon R2 root under R2 square plus X2 square. Put all the value of E2, R2 and X2, then you can get the current per phase is 11.2. And similarly, power factor equal to R2 upon R2 upon R2 root under R2 square plus X2 square. So 1 upon 1 square plus 4 square root under, then you can get 0.242. And the condition second is slip rings are connected to a star connected resistor of 3 ohm per phase. Here the value of R is 3 and this R1, so we can get R2 equal to 1 plus 3, that is 4 ohm per phase. And putting the then the formula of I2 equal to E2 upon root under R2 square plus X2. So put all these value, we can get the value of current. And similarly for power factor cos phi, that is R2 upon R2 square plus X2 square. So put the value of R2, then we can get cos phi square. In this both condition, slip rings are short circuit and another slip rings are connected to resistors of 3 ohms. We can get the value of current per phase and power factor. And our next numerical problem is a 3-phase 50 Hz induction motor with its star connected gives 500 volt RMS at standstill still between the slip rings on open circuit. Calculate the rotor current and power factor when slip rings are short circuit and the motor is running with a slip of 5%. The resistance per phase of rotor winding is 0.2 ohm and its inductance is 0.04. Frequency given 50 Hz, voltage 500 volt RMS, and the value of E2 equal to this 500 upon root 3, so 288.67 volt, and R2 given 0.2, X2 is 2 pi f into 0.04. This is a given this inductance. So X2 equal to omega L. Value of omega is 2 pi f into 0.04, so 12.56 ohm. And the next one, slip is 5%, 0.05. At running condition, we know ER equal to E S into E2, that is 0.05 into 288.67, that is 14.4335 voltage, and XR equal to S into X2. Value of S is 0.05 and X2 12.5, so we can get 0.628 ohm. And again the rotor current equal to ER. This is the rotor voltage and this is the rotor reactance, so ER upon XR. Then we can get the value of ER is, we have already defined above, this value, and XR is 0.628 upon R square plus X square. So the value of R is 0.2 and value of XR is 0.628. Then you can get I2 equal to 21.8189 ampere. Now power factor equal to R2 upon XZR. Then put the value of R2 and XR equal to R plus XR or root under whole square. Then you can get power factor equal to 0.303. Similarly, next problem is 208 volt 60 Hz 4 pole 3 phase induction motor has full speed of 1755 rpm. Calculate synchronous speed and the slip and rotor frequency. First of all, this value of n is given 1755 rpm, and synchronous speed, we know synchronous speed equal to 120 f by p, that is 120 into the frequency is 60 Hz, so 60 by 4, that is 1800 rpm, and slip equal to S equal to ns minus n upon ns. So put the value of ns and n, we can get the value of slip. And the rotor frequency, we know rotor frequency equal to S into F, that is slip into frequency, so 0.05 into 60, that is 1.50.